All right, let's take a look at two terms here, resonance and damped oscillations. Now, both of these are kind of terms that help us change the amplitude of our oscillation. In order for resonance to occur, the frequency of the oscillation has to be equal to n times whatever your driving frequency is, where n is some integer, or I'm sorry, whole number 1, 2, 3, and so on. The key idea here is that it's going to increase the amplitude. So if you went out to a swing set and you were pushing your friend, like if you push them every time, that amplitude is going to hopefully increase, assuming you're putting in more energy than friction is removing. You're going to get an increase in amplitude. Now you could also push them every other time. And when you push them every other time, yes, you can still increase the amplitude. And so that would be an example where maybe n is equal to 2. Or you could push them on every third turn. But the idea is that you can't just push them any old time. You have to have your drive frequency, the frequency at which you are pushing them, has to somewhat match that frequency with which they're naturally swinging. I can't just like do this. It's not going to be effective. Okay? As far as damped oscillations go, this will change our amplitude. Typically we lose energy, so this is just showing us losing energy. It can cause a change in frequency. Typically we're not going to do any calculations where it does change the frequency because then it's no longer simple harmonic motion with just a slowing amplitude. It's a different type of problem to do. So we are just going to keep it that way. There's not many of these on the AP test, so I wouldn't get too worried about dealing with this. Every once in a while you'll see a scenario where it's like, hey, let's look at this graph, see how much energy was losing. Was it losing it linearly? Was it losing it exponentially? And it can lose it in either circumstance. It's typically an exponential loss of energy, but you can find it linear. There you go.